All right, so given this, prove it's a parallelogram but not a rectangle. So I'm going to go ahead and draw it. I'm going to kind of estimate where it goes. I'm going to make 2 boxes. You can make 1 if you want to. I'll make 2 boxes equal to 1. All right, 1, 2, 3, 4, 5. Okay, and because this is an estimate, I'm going to go over the grid. I don't really care about being entirely accurate. I just want to see where everything goes. -1, -2, -3, -4. 1, 2, 3, 4, 5, 6. All right, so once you have it, go ahead and plot. So -2, 2, -2, 2. It's going to be point A. Point B is 6, 5. So 6 and then 5. Again, I'm off the paper just because my 6 goes off the paper. 4, is that 4, 0? Yeah, 4, 0. So 4, 0, point C. -4, -3, -4, -3. That's point D. All right, best. In fact, you know, I don't even know why I'm doing this because I have a ruler. But anyway, doesn't really matter. So that's what it is. Okay, so the question is, it's a parallelogram but not a rectangle. Okay, so a parallelogram, remember, has the 5 properties. A rectangle has the 5 properties plus 2 more. So in order for it to be a parallelogram but not a rectangle, I need to prove one of these things. Either vertex angles are 90 or diagonal lengths are congruent. If I prove one of those 2 things, then I've proved it's a rectangle. I kind of, distance for me kind of takes too long. So I am just going to tell you about it, and then I'm going to do it the other way. But if you are doing distance, you know that the diagonals, that and that, are equal. So if you do the distance between AC and that's equal to the distance between BD, then it's a rectangle because the diagonals are equal. In a parallelogram, they're not. What I'm going to do is I'm going to prove, and it doesn't matter which one I prove. If it's a rectangle, you know the vertex angles are 90. So if I prove that the slope between AB and AD is equal to 90, then, or rather perpendicular, then it would be 90. So then that would prove it's a rectangle. Or I could look at the slope of AD and BC, CD, or I could look at the slope of DC and BC, or I could look at the slope of AB and CB. Doesn't matter which ones, but whichever ones I pick, if you take the slope and you flip it and change the sign and then equal to each other, then it's perpendicular. If it's perpendicular, that means it's a rectangle. Or you could just do diagonals are equal, whichever one. I'm just going to do slope. So I'm going to do the slope between AB, slope of AB and AD. And if whatever those are, if I can flip it and change the sign and they're equal to each other, it's a rectangle because it will mean that they're perpendicular. So looking at the slope of AB is going to be rise over run. So I'm going to rise 1, 2, 3. So I'm going to rise 3. And I am going to run 1, 2, 3, 4, 5, 6, 7, 8. So 3 over 8, can I simplify that? No, that's what it is. All right, AD, slope between A and D. I'm going to rise, and I'm just going to look at the x-axis, -3. So that's going to be 3 to there, to 2, so 5. So I'm going to rise 1, 2, 3, 4, 5. And I'm going to run, so once I've risen 5, I'm going to run 1, 2. Can I simplify that? No. All right, looking at these 2 slopes. If I flip one, doesn't matter which one you pick, so I'll do this one. If I flip this one and change the sign, it's going to become 8 on the top, negative, and then 3. Is this the same as that? No. Because they're not the same, it's not a rectangle. They're not perpendicular. If I had flipped it and changed the sign and then they were the same, then it would have been perpendicular. So I just proved that that is not a rectangle. All right. Again, you could have proved the diagonals are not equal, and that would have done it too. All right, number 6. All right, looks like they're really big numbers, so I'm going to make each box count as 1 just so I can have space. -1 is my smallest x, and my smallest y is -5. So I'm going to draw my axis like this, really close to the end there. And -5, I need to make sure I have 5 boxes, so 3, 5. All right, somewhere there. Y, X. All right, then, go ahead and label. I'm going to go up by 2s, it's just faster. So that's 2, 4, 6, 8, 10, 12, 14. And I think I only needed to go to 11, so that's fine. We'll go by 2s, 2, 4, 6, 8, 10, 12. All right, go down by 2s, -2, -4, -6, and this is -2. All right, again, once I have it labeled, go ahead and plot the points. So -1, -5, so -1, -5. That's going to be point A. 8, 2, 8, 2. That's going to be point B. 11, 13. So 11 and then 13. It's going to be point C. 2, 6, 2, 6. That's going to be point D. Right, drawing the lines as best as you can. All right, now look at the question. Using the chordate geometry, prove that the quadrilateral is a rhombus, okay? So, again, a rhombus has 5 plus 3. The 5 things make it a parallelogram. The 3 things makes it a rhombus. All right, so we either need to prove all sides are equal, but be careful with that, because if I prove all sides are equal, it could be what as well? It could be a square. All right, diagonals are perpendicular. Diagonals bisect vertex angles. Okay, so think of that picture real quick. So I could prove diagonals are perpendicular, so the 90 is in the middle here. Okay, I could prove all of these are equal. I could prove that the vertex angles are bisected in half, or bisected, sorry. All right, so remember the 3 things we're working with is distance, midpoint, and slope. If I found midpoint, okay, it'll mean that they're bisected. Probably the best thing for me to do is I could do the distance with all 4, but that's just going to take too long. I don't feel like doing all that. I'll do the slope. If I did the slope of this diagonal and this diagonal, and I found that they were perpendicular, it means that they are 90s in the middle. So that's the one I'm actually going to choose to do. All right, so I'm doing the slope of A to C and DB. So slope AC, AC, and BD. Okay. Just in case I did not draw this. No, actually, I did. Okay. I'm just going to do rise over run. You could do y1, y2 minus y1 over x2 minus x1 if you want to. I'm going to do rise over run. So I'm going to go slope from A. Slope from A rising, it starts at -5, goes to 0, so that's 5, plus the 13 to go up here, so that's going to be 18. So 18 over, and then it starts from -1, and it's going to run 1 to 0, and then to 11, so that's going to be 12. Or you can literally count the boxes, okay? I just don't feel like doing that, but I'll show you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Then you run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, I'm just trying to show you how to get there faster. All right, so let's simplify that. All right, let's divide by 2, I guess, get 9. Divide by 2, get 6. Divide by 3, get 3. Divide by 3, get 2. So simplifies to 3 over 2. All right, then you look at the slope from B and D. Okay, slope of B to D. All right, so again, it's rise over run. So you're going to rise from 2 to 6, so that's going to be 4, or you count the boxes, 1, 2, 3, 4. All right, then you're going to run to the left, which means it's going to be a negative. And you're going to run either count the boxes or go from 8 to 2, which is 6. 1, 2, 3, 4, 5, 6. All right, let's simplify. All right, by 2 is negative 2. By 2 is 3. So now this is the slope. Now, remember, if the slopes are perpendicular, that means it's 90s in the middle. All right, so we're going to pick one. It doesn't matter which one you pick. You could do either one. All right, let's pick this one. You're going to flip it, so it's going to become 2 over 3, and then change the sign, negative. Then you're going to ask yourself, is that equal to that slope? If it is, then it is perpendicular, which means you have 90s in the middle. So that is a rhombus. Alternatively, you could also find the distance between AD, DC, CB, and BA. Okay, it's just that it's 4 calculations, so I'd rather do the 2. And that's how you find number 6. All right, finally, number 7. Okay, smallest is going to be, what's the smallest? 2 to highest, 9. Okay, negative 3, okay. So x doesn't even have any negative, so let's go. And y has negative 3. Okay, I'll do one box each, so I'll do it around here. All right, and again, I'm just going to go up in 2s just to kind of save time because I don't have time to label every single thing. So 2, 4, 6, 8, 10, 12, 14, negative 2, negative 4, 2, 4, 6, 8, 10, 12, 14, negative 2, negative 4. All right, once you have your x and your y-axis, plot it. All right, so 2, 3. So 2 and then 3. That's going to be right there. Point A. 7, 10, 6, 7, and then 10. Right there. Point B. 9, 4. So 9 and then 4. Right there. Point C. And then 4, negative 3, negative 3. Point D. All right, go ahead and join them up. All right, now, it does kind of look like a rhombus actually, but it says prove that ABCD is a parallelogram and not a rhombus. All right, so again, remember, for a rhombus, a parallelogram has 5 things, a rhombus has the 5 things plus 3 more. So if I can prove the 3 things, then I'll make it a rhombus. Without the 3 things, it's not a rhombus. So I need to check all sides are equal, diagonals are perpendicular, or diagonals bisect vertex angles. Okay, so since we just actually did a question like this, maybe I should go ahead and do the distance way. Again, it's just going to take so long. I don't feel like doing that. So let me just do the slope. If the slopes of the diagonals are perpendicular, then it's 90 in the middle. So let's check that. So it's going to be the slope between, slope between BD and slope between, I guess I'll do it at the bottom here, slope between BD and AC. And again, you could do y2 minus y1, or you could just count, whatever you want to do. All right. But we draw it so we can count. It's just a little bit faster. All right, so from B to D. So rise over run. So it goes from negative 3, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Rises 13, and he runs 3. I'm just going to check that. So from here is 3, and then to 10, 13. And then this is 4 to 7, so it's 3. Again, I don't like counting because the boxes kind of zoom in and out. I don't know if it's the grid is really small or something. I'd rather do it by numbers. Can I simplify that? No, so that's what it is. All right, so then AC, A to C, rise over run. And you'll notice what I'm going to do on this next one is I'm just going to show you how to use the coordinates. And you're going to have to get really good at this anyway, so I might as well give you a head start. So from A to C, I'm going to rise because C is 1. And then C goes XY, it goes all the way to 9 from 2. So from 2 to 9 is actually going to be 7. But again, you can count 1, and then 1, 2, 3, 4, 5, 6, 7. So these are my two slopes. All right, pick one, doesn't matter. Let's pick this one. Flip it, so it's going to go 3 over 13. Change the sign. Is this slope equal to this slope? No, because they're not equal, the diagonals are not perpendicular, therefore it is not a rhombus. Again, you could do this using distance. I just don't want to go into that now. When you get into the next unit, actually, you're going to do a lot of distance. It's just what's going to come up. But I'm going to show you a shortcut to do it. So we'll look at that once we get in there. Since we have a little bit of time, actually, I'm going to go back to number 4 and do it because it's not really that difficult. Same thing as before. Given this is the quadrilateral, blah, blah, state the coordinates of the prime, the post image, the image of the color under dilation of 1/2. Remember, or you don't know this yet, but in order to do dilations, all you do is you multiply everything by 1/2, and then you've dilated it by 1/2, and then draw it. All right, so we're going to dilate everything by 1/2, so multiply -2 by 1/2 is -1. Multiply that by 1/2. Oh, I'm tripping. 2 times 1/2 is 4. I'm trying to take just 1/2 for whatever reason. I'm tripping. No, sorry. It's -1. Yeah, sorry. All right. 2 times 1/2 is +1. 2 times 8 is 4. So B prime is going to become 4. And that's going to become -2. That's going to become 3. -5. -2 and -2. Okay, so those are your new coordinates, and because they're not very big, I'm going to make 3 boxes. Yeah, I'm going to make 3 boxes apiece. So again, draw your X and Y. Should I do 2 boxes? 2 boxes is 1. 2 boxes is 1. Two boxes is 1, so 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -1, -2, -3, -4, 1, 2, 3, 4, 5. All right, then you just plot your new points. And again, if you didn't really understand what I just did there, that's okay. Just wait for the unit. It's really what we're going into next. It's no big deal. -1, 1, -1, 1. That's point A prime. 4, -2, 4, -2. That's B prime. 3, -5, 3, -5. It's going to be C prime. And then -2, -2, -2, -2. It's going to be D prime. So again, go ahead and join your lines. And then prove that is a parallelogram. Okay, so again, let me prove that this slopes are equal. So slope of AD, or even better, let's do midpoint. Okay, midpoint of A prime, C prime. And D and B. So midpoint of D prime, B prime. All right, so write down the coordinates of A is -1, 1. C is 3, -5. D is -2, -2. B is 8, -4. Midpoint, what do? Add them together and divide by 2. So that's going to be 2 divided by 2. It's going to be 1. 1 plus -5 is -4 divided by 2. It's going to be -2. -2 is that, is 6 divided by 2 is going to be 3. -2 plus is going to be -6 divided by 2 is -3. All right, that was the bell. I'm going to have to come back to this question.